begin in the beginning. We live on Earth, and as you all probably know, it is the third planet in a solar system on the outer edges of a spiral galaxy in a universe that began billions of years ago. In fact, our planet dates to about 4.5 billion years. But the strange thing is that Earth's first rocks, the earliest rocks that were laid down, are really quite rare. We find some of these in southwestern Greenland and in northern parts of Canada. And these tend to date around 3.9, 3.8. There's some suggestions that there might be some 4 billion year old rocks. In South Africa, the oldest rocks we have come from the northern part of the country in an area called Barberton. These date to about 3.5. And in fact, these are really special because they preserve traces of the earliest life forms on Earth. Now, some of you might know that the preserved remains or traces of organisms are called fossils. I'm not sure how many of you do know that not everything that ever lived is preserved as fossils. There are very special circumstances that are required for fossilization of plants, and different set of circumstances are required for the preservation of animals. Soft-bodied organisms are rarely preserved. That's why much of the fossil record is made up of hard parts of animals, their shells, their skeletons, and their teeth. So most of what we know comes from the hard parts of organisms that lived before. Despite the gaps in the fossil record, we have an incredible fossil record where we can track how life progressed over time. We know that it began 3.8 billion years. And from this fossil record, we are able to understand when different life forms evolved. We can see how they diversified and also when they became extinct. In almost every case, when we see this incredible biodiversity around us, we should realize that all of them, all animals and plants, are really endpoints of long evolutionary histories. Many of them have had side branches, so kind of relatives that had gone extinct, and their lineages are represented today. It is quite humbling for us to realize that all the biodiversity around us is really a very small fraction of the total biodiversity that once existed. There are several major episodes in the evolution of life on Earth. The first of these, I guess, is the very origin of life. The development of multicellular organisms is another one. We see this happening at about 2.1 billion years. The next big step in the evolution of life on Earth is this major diversification that happened in the Cambrian about 542 million years ago. Thereafter, we see the movement onto land as very significant. First, plants make this move about 473 million years ago, and then animals move onto land about 380 million years ago. The very, very important step in the evolution of vertebrates is the development of reptiles. And they become the amniotes, which later we'll see give rise to the mammals as well as to birds. And this happens about 350 million years ago. So the actual origin of life is probably one of life's biggest mysteries. It is possible that life may have formed originally within the oceans, but there's also another hypothesis that suggests that life may have come in from outer space. And this idea has gained momentum because we know that there are many meteorites that have been found where there are a suite of amino acids on them. So amino acids, as you may know, are the building blocks of DNA. And DNA, of course, is the essence of the self-replicating molecule that developed in the evolution, the first stages of life. So once we have DNA, Darwinian evolution can occur. And through this process, we see this incredible diversity of life that we know on our planet today.